The question says, how will you bring about the following conversions? First conversion is convert ethanol into but1ine. Let me write the chemical formula. Ethanol is CH3CH2, it is OH, to be converted into but1ine. CH3, it is CH and C triple bond and CH is there. Okay. And before carrying out the conversion reaction, always check the number of carbon. This side how many carbon? 2 carbon. This side how many carbon? 4 carbon are there. Okay, so first of all we need to balance the number of carbon. Okay, number of carbon. Now pay attention carefully. You can see 2 carbon, this side 4 carbon. So we need twice of carbon, and to double the number of carbon we always follow Wood's reaction. Okay, and Wood's reaction, when alkyl halide is there, alkyl halides undergo Wood's reaction. So first of all we can convert alcohol into alkyl halide. Okay, by using halogenating agents, any of these agents you can use. SOCl2, PCl3 or PCl5 is there. Any of these halogenating agents we can use. So OH is replaced by Cl, we get CH3, this is CH2 and this is Cl is there. Now we can carry out Wood's reaction. From here we get sodium. Okay, 2 molecules of alkyl halide we can take because 2 Cl are there, and then we need 2 sodium. Okay, and we use dry ether is there. So 2 carbon multiplied by 2 is equal to 4 carbon. We get CH3, CH2, CH2 and then we get CH3. Okay, number of carbon are balanced. Now we start working on making this saturated carbon chain into unsaturated carbon chain. This is alkane, this is alkyne. Okay, now pay attention carefully. If we carry out halogenation, need some space. Now let's see if I carry out halogenation. Okay, so in this case if I carry out halogenation, this is what Cl2, it is HV is there, Cl2HV. Okay, so reaction is taking place in the presence of sunlight, and we always form the product from more stable free radicals. So you can see this is the secondary free radical, this is secondary, this is the primary, first degree carbon are there. So we have to halogenate the second degree carbon. Okay, halogenate. So I do one thing, we have 2 hydrogen are there, so I write here hydrogen dot dot, hydrogen dot dot. Okay, then I take 2 molecules of Cl2. So 2 HCl will be removed because from here Cl dot is there multiplied by 2. So 2 HCl are removed. Then we get CH3, this is CH2, this is C and it is Cl and it is Cl, and then we get CH3 is there, CH3. Now we can carry out elimination reaction. We carry out elimination reaction. Now you may think if I carry out elimination reaction, so you can see to form the stable product, to form the symmetrical alkyne, you have to take hydrogen from here, hydrogen from here. So HCl will be removed from here, HCl will be removed from here. 1 HCl result in the formation of 1 pi bond. Then since we are removing 2 HCl, 2 pi bond will come here. This will be but2ine, and we need but1ine. Okay. But if we get but2ine, that will be Sedgef product. Okay, and if I have to get but1ine, then we can form Hofmann product. Okay, Hofmann product. How we form? You can see if I take KOH, and this is what alcoholic is there, it will cause elimination reaction. Okay, by using this base, it will be forming Sedgef product, and the product will be but2ine. I remove this one. Now I take bulky base. We have tert butyl oxide potassium is there, potassium tertiary butoxide. Bulky base is there. Due to the steric hindrance, it will not be attacking the crowded carbon. You can see second degree carbon is more crowded than first degree. So that's why, to avoid the steric hindrance, because it is already bulky, tertiary butyl is there, means tertiary butyl C and C is there. This is bulky, and O and it is K. This is the chemical formula. It is negative, it is positive is there. Okay, so this is the structure. We already is bulky. So it will not target the hydrogen to the second degree carbon. It will target the side carbon, because here we do not have the steric hindrance. So it will start removing hydrogen from this carbon, Okay, so we have So I remove one HCl from here. I do one thing, remove HCl from here. This is one H. Here we have one H. One HCl removed from here, one pi bond. One HCl we removed from here, one pi bond. Then we get the product CH3, CH2, and C triple bond, and CH is there because we have removed two HCl. Okay, two HCl. And it is a strong base will neutralize a strong acid. Okay, so this is what half-man product. We have half-man product is there. Okay, so very interesting part. Always check the number of carbon atom on both sides before carrying out the conversion reaction. Now move on to the next conversion. Second, we have ethane to bromoethene. Ethane to bromoethene. So this is what we have. Second one, ethane CH3, and it is CH3 is there, and it is to be converted into bromoethene. This is what Br ethane is there. CH double bond and CH2 is there. Okay. So first of all, we have to carry out unsaturation. So I do one thing. I make it react with two molecules of Cl2, and this reaction is taking place in the presence of sunlight. Better I write HV, that is better. Okay, so we can get CH3, this is CH, and it is Cl is there, this is also Cl is there. Okay, I can write like this also. This is what Cl is there. Better I write like this. This is CH H, and this is C H, and this is Cl, and this is Cl is there. That will be better because ultimately I am going to draw this structure. And why we are carrying out halogenation? Because we have to remove HCl, one HCl, one pi bond, another HCl, another pi bond, because we are going to convert into alkyne. Okay, so we use first one is KOH, alcoholic is there. So from here HCl is removed, pi bond generated. Okay, again we can use another base. We have NaNH2 also. NaNH2, it also cause elimination reaction. From here we remove HCl. Because Na will combine with Cl, neutralize, NH2 will combine with H, forming ammonia gas, escape. Okay, so we remove one HCl, one pi bond, and another HCl, another pi bond. We got CH triple bond, it is CH is there. Okay, now we can make it react with HBr. Okay, so it is a symmetrical alkyne. Break it is positive, negative, it is positive. Break one bond, it is positive, it is negative. Okay, form the product. So Br will attach to this CH and H will come here, so it will convert into CH2. Okay, so reaction is completed. Move on to the third one. Third conversion, it says propene CH3, it is CH double bond, CH2 is that it is to be converted into 1 nitropropane. This is what CH3, it is CH2, and CH2 it is NO2 is there, 1 nitropropane. 1 nitropropane is there. Now directly we cannot carry out nitration because it is not aromatic reaction where you can carry out a nitration, that is electrophilic substitution reaction. Okay, so first of all we can convert into alkyl halide, and then we make it react with AgNO2. Alkyl halide reacting with AgNO2, so in place of Cl, in place of halogen, NO2 will introduce. Okay, keep in mind alkyl halide reacting with AgNO2, they form this is what RNO2, and if I take alkyl halide reacting with KNO2, in this case we get the product RONO. You should be careful. Okay, so I make it react with H. Okay, I need halogen at the end. At the end we need primary alkyl halide. Keep in mind, if I need primary alkyl halide from alkanes, we follow anti-Marconi-Ka rule. From anti-Marconi-Ka rule we will get primary alkyl halide, and from Marconi-Ka rule we get secondary alkyl halide. So I do one thing, I make it react with HBr and use the peroxide effect. We have H2O2 is there. Okay, so in this case this is negative, this is positive. Br minus will go to the carbon having more number of hydrogen. Okay, so Br will attach here. We got CH3, it is CH2, then we got CH2, this is Br is there. Okay, Now we make it react with AgNO2. AgBr will be removed from here. AgBr and NO2 will occupy the place of Br. Okay, so one nitropropane. Move on to the next one. We have the fourth one. It says toluene, methylbenzene. Toluene is nothing but methylbenzene is there. Okay, it is to be converted into, this is what benzyl chloride. Very interesting. Benzyl, we have benzyl, CH2 is there and then Cl is attached. Benzyl alcohol, sorry. So let me attach OH, there's no problem. So first of all we can form a benzyl chloride and then we have benzyl alcohol, no problem. Okay, this reaction is quite interesting. Why? Because see, I have to carry out halogenation. So what kind of halogenation? Electrophilic halogenation reaction, yeah, free radical halogenation reaction. Keep in mind, if I carry out free radical, so you can see it, free radical, if I carry out halogenation Cl2HE, then branch chain will get halogenated. Okay, and if I make if it carry out electrophilic halogenation reaction, then this benzene ring will get halogenated. This difference you should keep in mind. Okay, if I make it react with Cl2, it is HU is there, so this chain will get halogenated. But if I make it react with FeCl3, this is what Cl2, then in this case this benzene ring will get halogenated. Okay, so I do not use this. Okay, I need halogen attached to this carbon, because here we are making change. Benzene ring is same, so we are not going to disturb this benzene ring. We have to focus on this carbon. Here I halogenate. So this reaction takes place via free radical mechanism. So I do one thing. We can write it. This is what CH3 is there. So we mention CH2. It is H. So you can see one dot will come here. One dot will come here. Here also from Cl2 we got Cl dot, and this is what we have Cl dot is there. Cl dot. So H dot Cl dot will combine, remove, and this Cl dot and CH2 dot will combine, forming what? Benzyl chloride. So this is what we have CH2 and this is Cl. Okay. Now in place of Cl I need OH, then carry out a nucleophilic substitution reaction, use KOH, and this is what aqueous is there. Okay. So KCl will be removed from here, OH will occupy the space of Cl. Benzyl alcohol. Last one, propene to propyne. We have the fifth one, propene, CH3, this is CH double bond, and this is double bond CH2 is there. Sorry, let me correct it. We have fifth one is there, CH3, this is CH double bond CH2 is there, and it is to be converted into CH3, this is C triple bond and CH. Okay, one more pi one we have to introduce. Okay, number of carbon are same, so we do not focus on the changing the number of carbon. Okay, focus on converting double bond into triple bond. Okay, so you can carry out halogenation reaction, then we have to carry out elimination. When we carry out elimination reaction, pi bond is introduced. So I do one thing, I make it react with, we have a, let's say if I make it react with no, it will not work out. If I make it react with HCl, so C will come here, H will come, again halogenation. Okay, two halogens we have to introduce. So better I convert this unsaturated alkane into saturated. That is better. So we have nickel and H2 is there. So break this bond, attach hydrogen on both sides. This is a reduction reaction. Okay, so we have used reducing agent carrying out reduction reaction. So we got a saturated hydrocarbon CH3, this is CH2 and this is CH3 is there. Okay, now make it react with the Cl2. We have Cl2, this reaction taking place via free radical mechanism. So we have to form the major product. So focus on the second degree carbon. These are the primary, okay, first degree carbon. So we have to form the product from the second degree carbon. Okay, so take 2 Cl2. So 2 H and 2 Cl will eliminate as a 2 HCl, and 2 Cl will connect to this carbon. We get this is what CH3, this is C, Cl, and this is Cl is there. I do one thing, CH3 is there. I can write CH, and this is H, and this is H is there. Okay. Now if I remove 2 HCl, 2 pi bond will introduce. So I do one thing, we use the base. First one was KOH, this is alcoholic. So 1 HCl is removed. You can take two molecules of KOH alcoholic, there is no problem. So the two HCl will be removed. And another we take this is what NaNH2 from here another HCl will be removed. So one HCl, one pi bond, another HCl, another pi bond. You can see this conversion is completed. If you like this video, please share and subscribe to the channel.